Welcome to Study Loop.
So in this problem, we have a 0.4 kilogram iron horseshoe, which is, let's say, at a temperature T. It is dropped into water, 1.05 liters of water, which is inside a 0.30 kilograms heavy iron pot. And this was at 20 degrees Celsius. So once this horseshoe was dropped in, after some time, the final equilibrium temperature of 25 degrees was reached. We want to find out what the initial temperature of the iron horseshoe was. So obviously, the heat lost from the iron horseshoe got transferred into the water and the iron pot. So the heat lost from the horseshoe is simply the mass of the horseshoe times the specific heat of the horseshoe, which is in this case made of iron. So specific heat of iron times delta T. Let's call this delta TH for delta T of horseshoe. Now this heat must be transferred into the iron pot and the water. So for the water, it is the mass of water, the specific heat of water times delta T. Water went from 20 degrees to 25 degrees, so that's 25 minus 20. Similarly, for the iron pot, it's mass of the iron pot times the specific heat of iron, because it is also made of iron, times delta T again is 25 minus 20. Now, the first term becomes, we know that the mass of the horseshoe is 0.4 kilograms, times we know that the specific heat of iron is 450 joule per coulomb degree Celsius, times we know that delta T would be 25 degrees, T minus 25 degrees. It goes from 25 T degrees Celsius to 25 degrees Celsius. Now this is equal to the mass of water is simply 1.05 kilograms. Remember that 1 liter of water weighs 1 kilogram, which means 1.05 liters of water weighs 1.05 kilogram, times the specific heat of water, which is 4186 times 5, or delta T, plus for the iron pot, we have the mass 0.3 kilograms times 450, or specific heat, times 5, or delta T. By solving this equation, we can see that the temperature of water is 150.8 degrees Celsius. But because our numbers have 3 or 2 significant digits here, we need to round it down to 2 significant digits, giving us 150 degrees Celsius.